Hi there. All right. Welcome to day whatever it is. We're covering section 2.3, changes of matter. And we're going to talk about physical and chemical changes and how you would, for instance, go through and separate out certain mixtures with some physical changes, and how you might actually separate out some of the components of a compound with some chemical changes as well. This is definitely an important question and an important thing to study, because even things like why does toast occur? Why can I heat up bread and it turns into toast, and that can't ever go back to bread again, yet I can heat up ice and it turns into water and it can go back into ice again. Okay, so these are some of the things that we're going to explore today. It's useful to your everyday life because you interact with this stuff in your everyday life, whether it be through your car, through your food, through your friends, your fish. I don't know. Let's have some fun here. Okay, here we go. We have got, let's get through that here. Let's look at our objectives here for today. We just want to classify changes of matter as either physical or chemical changes. Okay, so when I give you a change of matter, you should be able to tell me whether it's a physical change or a chemical change. So let's just think about this. If you heat a raw egg in water on the stove, you can get back the liquid water that kind of evaporated out, but you're never going to be able to get back the raw egg. Now, why is it? Why is it that the egg is different than the water? Well, the raw egg has gone through a change which is unique and different than the change that the water goes through. The water is going through a physical change, and the egg is going through a chemical change. And so that getting back part right there should be one of the indicators that helps you figure out, hey, this is one of the things that makes it different, makes a physical change different from a chemical change, right? Chemical changes you can't get back. Physical changes you can under ordinary physical means. All right, so chemical change changes the identity or composition and the properties of the substances. Okay, you'll see me use the word identity sometimes here. So composition or identity. And then, of course, if it's changing its identity, it's changing kind of what it does. It's changing some of its properties as well. So I can make toast by heating bread. That's a chemical change. That bread has become hard. It changes its taste. It's got some new properties. It's now hard. It now has a different taste. That is a chemical change. Now, physical changes can change some stuff too, but we have to remember that you can go back under ordinary chemical means. So I can take that water and I can heat up with some ice and turn it into a liquid water. It's going to turn right back again into a solid water if I cool it down again. Okay, so that's a physical change. It doesn't change the identity. The water is still water. The bread that has turned into toast, that'll never become bread again. And yet that ice that has turned into water can now, liquid water can now turn back into ice again. And so it keeps its identity if it's a physical change. All right, so let's look at evidences of chemical change. A change in color can be a great indicator of a chemical change. A change in temperature if you don't have an outside heat source. So in other words, this thing is actually getting hot or getting cold without having to heat it up or cool it down. It generates its own energy or sucks energy out of the environment. Okay, and there's a fun little experiment that we typically do in class, and we won't be doing it this year probably, but we might. We'll see. If we have time, we'll try to do it. The gas is given off, okay, so bubbling or a change in odor or smell. That could be an indicator of a chemical change. Liquids forming a solid. Okay, if you take two liquids, you put them together, and all of a sudden it turns like white or yellow or cloudy or something. That's called a precipitate. It's just another way of saying it turns into a solid. So those are all evidences of chemical change. So know those evidences. Gives off heat or light can also be another one. Gives off an odor. Okay, things like that. Okay, so make sure you know those. And now we want to identify these as physical or chemical. Melting, physical or chemical. Okay, maybe you want to pause it if you want to try these. Melting is physical change, right? Because it is going to be able to go back. Boiling, physical or chemical. And it's going to be physical. Burning. And this one's going to be chemical, okay? Once you burn something, it's not going back. And so that's going to be a chemical change. These two are going to be physical changes. Dissolving sugar in water. Now, a lot of students are going to miss this one. That sugar is dissolved. It disappears, but it's still sugar. It's still in there, and that's just a physical change. It just gets broken down into really, 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 really small pieces that you can't see anymore. And so dissolving sugar in water, that's just physical. You can go back to a separated sugar and water again by ordinary physical means if you just heat up that water and now the sugar's left, at the end, then you're all good, okay? Combining vinegar and baking soda. Now, you guys have done vinegar and baking soda experiments before, and these things cause a little bubbling, right? Cause a little volcano, and that gas is being given off, right? That's the indicator of a chemical change. Gas is given off. Rusting iron. This is a color change, right? Pretty dramatic change in color. And rusting iron is when oxygen and iron combine together and form a new compound. So that's a chemical change, all right? So we had physical, physical, chemical, physical, chemical, chemical, okay? All right, so let's look at some of our properties here. Chemical change versus physical change. Chemical change is changing the composition or identity. Physical change is not. Example, if I put vinegar and Tums together, that's going to be a chemical change. You are neutralizing the acid, okay? You might have some acid in your stomach and you take some Tums, you're like, oh, I feel better. Why? Because there's a chemical change taking place and the acid is being neutralized. It's turning into something that's not going to be as dangerous. Formation of a precipitate, that's that forming solid, rusting iron. Over here, we already talked about melting and boiling. Uh-oh. That one shouldn't be in there. You don't see that right there. That's not there. Okay. Dissolving sugar and water. All right. So now we got chemical versus physical changes. Okay? Okay, so I was talking to you about the sugar being in really small pieces. And so we just wanted to show you a little quick picture of that. This is called solvation. Okay? Solvation is when you have these little particles of water all attracting and pulling on those little sugar pieces, and it pulls the sugar pieces away from the other sugar pieces. And so it actually takes a molecule. Now, this sugar piece is, it's looking like a single sphere, but that sugar piece would be a much more complicated looking molecule. But it pulls it away, and each of these little particles of water are pulling it away until all of those big chunks of sugar are separated out, and now they're all these tiny little pieces surrounded by water in the substance. Okay, so mixtures can be broken down by physical or chemical changes. Why? Well, because they're not chemically bonded. Mixtures are not attached with bonds. They're just next to each other. They're free to move around each other. And so I can take a physical method and break up a mixture. There's also some chemical methods that I could use to break up mixtures too. We'll talk about one of those right now. Okay, if I took some acid and I had some acid that would react with one metal and another, and let's say I had a mixture of these metals all together, and I was like, I got to separate these things. Well, if I can put them together, have the acid react with one metal and not the other, then it's going to dissolve the one metal, and what I'll have left over is, something I can just filter out, and I'll have some metal that didn't get dissolved by the acid. So that would be a way I could separate those. Even though it's a mixture, I could separate that mixture by a chemical means. Kind of cool. And then I've got the ability to separate mixtures through physical changes. And again, these are very common, and you probably will see this on your catalyst. You're going to see an example of how can I separate some of these things out. Filtration, okay? You've seen coffee filters. You just put the filter, you put the coffee grounds in, and the water can go through, but the coffee grounds can't. That's filtration, right? So you can get some parts out and separate it out from others. Evaporation. If I just leave a jar of sugar water out for a while, eventually the water is going to evaporate. You're going to be left with some sugar crystals in there. Solubility. Well, if I have sugar and sand mixed together, and I take that sugar and I put water in the sugar sand mixture, the sugar is going to get absorbed by the water, and the sand is still going to be there. So I could pour out the sugar, water, and now I could take the sugar water and boil out the water, and I'd have the sugar, and my sand would be separated out. Okay, and I could separate that out through a filter. Magnetism. You guys have probably seen, let's say I have some mixture of iron filings and some sulfur, and I put a magnet around it. It's going to pull out the iron filings. It's going to leave the sulfur in because sulfur is not magnetic. Boiling point. We use this. It's called distillation, right? We use this process here to create liqueurs and things like that, where we want to try to get a high concentration of alcohol separated out from water. And so we ferment the material and then we distill it, and we use the boiling point because alcohol has a lower boiling point than water. And so the alcohol will come out first, and you can collect that. Melting point, like for instance, if you took zinc and copper together to make brass, if you wanted to separate them out again, you could then start melting them again, and they would have, one would melt before the other. Okay, not sure which one melts first. I think the zinc melts before the copper, but I could be wrong. Okay, so we have now talked about how to separate these mixtures, but could you separate a compound with physical means? No. You can't separate compounds through physical means. You can separate mixtures through physical means, but compounds have to be separated through chemical means because they are chemically bonded. They're actually connected to each other with attachments with their electrons, okay? So if you're thinking of a compound, it can only be broken down by chemical changes. So what's an example? How about when mercury 2 oxide is heated? Okay, then it breaks that mercury 2 oxide into mercury and oxygen. If I pass a current through melted table salt, I can actually end up getting sodium and chlorine separated out. That's kind of cool, right? If I open a bottle of soda, the carbonic acid in the soda is slowly going to break down into carbon dioxide and water. Okay, so why does your soda become less fizzy? Well, you actually have carbonic acid in your soda bottle, but it's going to turn into carbon dioxide and water, and then the carbon dioxide is going to escape. And so one of the reasons that your soda is acidic is because it's got that carbonic acid in there, okay, because of all the carbon dioxide that's combined with water. And so this one's pretty much a natural process, right? You don't have to really do much for this one. This one you have to take and apply electricity. This one you have to take and apply heat. Very, very often you're going to have to do something to get a chemical change to take place. But there's lots of chemical changes that are completely spontaneous too. Happens all the time in the world around us, right? Okay, so here is an example of the mercury 2 oxide. Here I've got a test tube, and I've got some mercury 2 oxide, which is kind of like this powder. And I take that and I heat it up under a Bunsen burner, and it's going to separate out into an oxygen gas and then the little mercury vapor, which is going to collect along the sides of the test tube. So that would be an example of what kind of a change? Chemical change, because it's changing the identity. Mercury oxide does not have the same properties as mercury and oxygen. Changes its identity. Okay? So let's look at what we've learned. Can we now classify changes? Whoops, going backwards. Oh, he's a little mean guy, isn't he? Can we now classify changes of matter as physical or chemical? Yeah. Okay, we could definitely go through and look at a change of matter and say, oh, it's physical. How do we know? Because it could change back, okay, or it's under ordinary physical means. Is it chemical? Oh, yeah, it's changed its identity, okay? So these are the ways that we would tell that. All right, well, that's it for today. I hope you learned some good stuff today. Nice quick lecture today, so have an awesome one. God bless you.